So about a year ago, I got an Android phone, and like many people, I thought I should probably write an app and make lots of money. So I thought for a long time about different ideas, and I finally came up with the next $1 million idea. What is the probability of seeing a rainbow right now? So before I could write the app, I had to do a bit of research about rainbows. So I learned about what rainbows are and how we can see them. Ancient people actually thought that rainbows were a bridge to the gods. Today, with fireworks and light shows, rainbows may not seem that impressive, but for ancient peoples, rainbows must have been pretty impressive. In the Bible, we have the story of Noah's Ark. After there was the flood that destroyed the world, God showed a rainbow as a sign that he would never destroy the world again. So if you want to know about when we can see rainbows, we need to know a little bit about what a rainbow is exactly. And in simplest terms, a rainbow is simply a distorted image of the sun. Now, it actually took scientists a long time to understand how rainbows come about. The first person to come up with a model of rainbows that we know about was Aristotle, and he had this model where the sky is kind of like a hemisphere, and we have some clouds, and the sun bounces off the clouds, and that's how we see a rainbow. He managed to get almost all the details completely wrong. So it actually took hundreds of years longer till people did work out how rainbows are formed. And what happens is light goes into a raindrop, it gets refracted by the raindrop, bounces off the other side and comes out again. And the angle between where it comes in and where it comes out is approximately 42 degrees. And so what happens is we have lots of these raindrops in the sky, usually in front of us, and then we have the sunlight coming and bouncing off all these raindrops. We have millions of raindrops bouncing off light. However, the only ones that we can see are the ones that are 42 degrees away from us. So that causes the arc shape. It would be a circle if we could see the ones that are underneath us. So I promised you at the beginning that I'd explain how to see a rainbow, and Charlie Chaplin once said, look up to the sky. You'll never find rainbows if you're looking down. And this is actually a picture here of my daughter, whose name is Keshet, which in Hebrew actually means rainbow. So it's actually easier. It's actually easier to say when there's not going to be a rainbow rather than when there is going to be a rainbow. If the sun is higher than 42 degrees, if the sun is set, if it's a sunny day, a cloudy day, or if there's a raining day, like we've had a lot of recently, you'll never see rainbows. So in order to see a rainbow, we need the sun to be below 42 degrees. We need to have some rain clouds in front of us, and we need the sun to be shining and behind us. So if you look forward, you should be able to see a shadow. And that's the conditions for seeing a rainbow. It's actually quite straightforward. So now I thought I'd explain to you about some of the more exotic rainbows that you're likely to see. This is the double rainbow. The double rainbow is actually caused, if the light bounces off twice within the raindrop, this causes a double rainbow, and it's apparently quite a life-changing experience. We also have tertiary and quaternary rainbows. This is when the light bounces 3 or 4 times inside the raindrop, and actually a lot of people thought they didn't exist. Only last year the first photographic evidence was found, and they're very difficult to see because you have to actually look into the sun rather than away from it. This phenomenon is called a cloud bow, and a cloud bow is caused by the much smaller drops that you find in fog or in clouds. The reason it's white rather than coloured is because those drops aren't able to refract the light as much. This next phenomenon is called a supernumerary rainbow, where we have these bands of light and dark light, and this is actually caused by the light on the way there interfering with itself. You have to read a physics textbook for more details on that one. This is actually a moonbow. Moonbow is like a rainbow but caused by the moon. Unfortunately, they're very rare, but the reason being is you need to have a full moon, you need to have the rain in the right position, and of course you need to have people awake at the right time to see one. So I'd like to end the talk today by dispelling a few misconceptions about rainbows. One of my pet peeves is children's books that incorrectly talk about rainbows. Take this example. You could never look straight ahead and see the sun and the rainbow at the same time. What about the end of the rainbow? Well, the rainbow is always 42 degrees away from us, and it's an illusion, and it walks with us, so you never actually can reach the end of the rainbow and the pot of gold and the leprechauns at there. I'm sorry. How many colours are there in the rainbow? Well, Aristotle thought there were 3, Newton thought there were 7. There's actually an infinite number of colours in the rainbow, ranging from blue to red. It just looks like bands of colour due to limitations of our visual system. Why are there so many songs about rainbows? Well, a certain frog would have you believe that there actually are a lot of songs about rainbows, but relatively speaking, compared to other meteorological terms, there aren't actually that many songs about rainbows. So just to conclude today, if you want to see a rainbow, you need the sun to be below 42 degrees, usually morning or late afternoon, sun behind your back, and the rain in front of you. And on that note, I wish you some good inclement Sydney weather so you can see lots of rainbows. Thank you.